All right, good day. We'll be talking a little bit about geothermal energy today. Heat from the earth, which is a nice, clean, sustainable, renewable way to generate electricity at the power plant scale. Or you can use this in your home to supplement your home heating or cooling system and save energy there. You're not going to use this to generate electricity at your home. You're going to use it to save energy through using the heat of the earth or the cooler temperatures that are underground in the summer. So there's two types of geothermal energy. One, where we're going to generate electricity at the power plant scale, and two, we're going to save energy in the homes or businesses where this is viable. So let's go through this quickly. Geothermal power plants are only viable, practical in areas where there is heat underground. So California, being a state in the United States that takes advantage of geothermal heat to generate electricity at the power plant scale. Iceland is a country around the world that does a good job of this type of energy. So just like most forms of energy, we're going to generate heat. We're going to use the heat to generate steam to turn a turbine, hooked to a generator. So the best case scenario is if you can find a place where the heat underground is hot enough to turn the water to steam for you. Then you have the kinetic energy of the moving steam. You just have to drill a well underground and allow that steam to move up the well towards a turbine, where the turbine will start to spin, and then hook it to a generator. So a very easy, simple way to collect energy and convert it to electricity. Oops. All right, so here's a couple of pictures of what this might look like. So here we have our plant. That's where the mechanics are, the turbine, the generator. You see a lot of the steam coming out there. So our steam well is tapped into a reservoir, an underground water supply. All right, and then underneath that is where the heat source is, the heat of the earth itself. So in this case, the steam is coming up our well, okay, and entering the system, funneled toward a turbine, hooked to a generator. All right, in this case, in this picture, they have a reinjection well. So what happens is the water is recondensed over here, and a pipe would funnel and filter the water back underground and pump it back down underground. All right, closing the loop. Okay. So you can recondense the water and have like a little closed loop system here. This plant that's pictured is called the Geysers, which is in Northern California. It's one of the bigger, more productive geothermal power plants here in the United States. Okay. Clear all? All right. All right. I'll go through this real quick. There's a couple of different ways you can generate steam. All right, this one's called a dry steam procedure, where we're going to use hydrothermal fluids. That's a funny word or a fancy word for water. All right. They're going to say hydrothermal fluids because it isn't just water. There's things in it. One of the things is hydrogen sulfide. Hydrogen sulfide is, something that makes the water smell like rotten eggs, sulfides. So hydrogen sulfide is something that you might want to remove from the water in this process because it could, I don't know, not damage, but have an impact on the mechanics, the mechanical parts of the system. So if you're removing the hydrogen sulfide, you can, ensure the efficiency of the system. But you can consider that a pollutant. if you keep the hydrogen sulfide in, it might not only damage or decrease the life cycle of the system itself, but you're going to release it into the atmosphere if you're releasing some of that steam into the atmosphere. So now you're a source of pollution. So there's systems in place, they call them abatement systems, to remove the hydrogen sulfide from the water so that while you're creating that steam, it is literally just steam or water. All right, so it's clear all here. All right, so the dry steam power plant uses fluids that are primarily steam. It goes directly into the turbine, boom, and that turbine starts to spin. All right, and then that steam continues on its way through the pressure within the pipes back down into the well. All right, so we're going to inject it back down underground. All right, so as that turbine spins, it's connected to the generator from this rotor. Remember, a generator is just a series of copper coils that converts mechanical energy into electricity. Okay? All right, so let's see what this says. Steam eliminates the need to burn fossil fuels to turn the water to steam. All right, so that's one of the ways this system is sustainable. All right. Another type of geothermal is called a flash steam power plant. All right, this system is going to use really hot conditions here. So the water is going to come up into this little separate tank that they call a flash tank. And what's going to happen is it's going to flash boil that water. It's going to literally vaporize it. So fluid is sprayed into a tank held at much lower pressure than the fluid, which causes it to rapidly vaporize. Right? They call that flashing. All right, that vapor then is what turns that turbine to generate electricity. All right, continues on its way back down the injection well. So the only difference here is in the other one, the steam is coming up and literally just turning the turbine. In this case, we're going to take the hydrothermal fluids and literally flash them, vaporize, so that it can turn the turbine. All right, next one. And this is the one that's more popular. It's becoming more popular, and you'll see why here in a second. A binary cycle system is where our production well is providing the water or hydrothermal fluids. All right, in this case, those hydrothermal fluids are not going to be what's turning the turbine. They are instead providing the heat to the system. All right, I'll just put a box around this. We're going to use what's called a heat exchanger. So we're going to exchange the heat from the water coming up the system and use that heat to boil our pure water that continuously cycles through here. So the water will turn to steam, which will turn the turbine. All right, it will recondense over here, coming back down to be boiled again, to turn the turbine again. So you have a closed system up here turning this turbine, and you have a closed system down here providing the heat. The heat exchanger exchanges the heat from the already hot water coming from underground, providing the heat to drive that steam, turning the turbine. All right. What makes this so popular is that, like I was saying, with one of the things is that hydrogen sulfide. We don't have to worry about that now. You don't have to use abatement systems or anything like that. You have control over the purity of the water that's being turned to steam to turn your turbine, and everything's a closed system. So that's what makes this so attractive. Okay. All right, you can read this. Just another bit of, oops. Okay, the next thing to talk about is geothermal heating and cooling systems for your home. So this would be a situation where you have the ability of using, here, let me do this. Whoops. Home, there you go. You have the ability of taking advantage, I like it says that, of the temperature underground to either heat or cool your house. Now, you're going to use this as a supplement to your heating or cooling system. This alone is not going to provide all the heat you need in your house. Underground, you need to know that it's always and consistently about 55 degrees underground. All right, so if you can bring 55 degrees into your house in the wintertime, so let's say you're bringing 55 degrees in the house, then you only need to heat your air in your home from 55 to 70, or whatever you set your thermostat at. If that wasn't the case, you would be heating your home from whatever the temperature is outside to 70 degrees. So you're saving the amount of energy it takes to heat your house. 55 minus 32, 23 degrees. You're saving that energy constantly to heat your house at 23, to heat your house, to heat your house. So I hope that makes sense. If you don't have geothermal, you need to heat your house from 32 to 70. If you do have geothermal, you need to heat your house from 55 to 70. So you're saving that amount of energy to heat your house 23 degrees. So hopefully just saying it one more time makes sense. All right, and then the same thing in the wintertime. You're going to cool your house from 55 to 70 instead of, I'm sorry, hold on. All right, so here's a picture of what this might look like. A very simple system. Over here is the winter time. All right, so you're using a heat pump, and literally that is just pumping water down, let's say out into your yard, and then down underground, all right, below the frost line, where that temperature under the ground is about 55 degrees. So as that water assimilates and becomes 55 degrees, it's going to bring 55-degree water back into your house. So that's going to transfer that temperature into your system in your home, and your heat pump will convert that temperature to air. We'll put it into the air and then blow that 55-degree air around your house. Oh my gosh. Here we go. All right. So then your heater just needs to heat the rest from 55 to 70. In the summertime, all right, same thing. So you're going to pump water, whatever temperature it is in your house. So let's say it's 65 or 70 degree water. All right, it's going to pump it underground. That water will turn to 55 degrees. So now it's going to bring that cooler water, which will then cool some of the air. So you have to use your air conditioner less. All right, that's the idea of geothermal. So over on this side, it shows you a diagram of what a system might look like. A series of pipes dug out into your yard and then down below the frost line. And there's a couple of different types of system, horizontal loops, slinky loops. But that's the idea, is using the heat or the cooler temperatures underground, in the summertime in that case, to supplement your heating and cooling in your home so that you can save energy and use less. Save you money too. Okay. Con, these systems are expensive. You need the land to do it. Just the cost. The cost is what is the main deterrent for most people. But if you can do it, you can get a grant from the government, 30%, rebate, something like that. Make it work. It's extremely viable. All right. Just another picture of the same thing. You can pause and look at that if you like. All right. From the power plants side of things, the advantages: clean energy, which means no pollution. It's renewable. All right. The power stations have a low footprint. There's really no fuel required. The earth itself is providing the water and the steam. And then after the initial building cost, just keep it running. Disadvantage, you're limited to where you can do this. Maybe you can run out of steam, the source. If the groundwater supply becomes unreliable. And then there's that hydrogen sulfide, the harmful gases. All right. Sulfur dioxide also. Okay. Okay. Hopefully that gives you a little sense of geothermal. All right. It just takes somebody to explain it to you. What a great way to generate energy, especially if you're Iceland or California, where energy demands are really high and costs are high. What a nice renewable way to supplement energy going onto the grid. All right. Let me know if you have any questions. Hope this makes sense.